Halide ions. So describe the test for halides. Well, we want to add dilute nitric acid, then we want to add a few drops of silver nitrate solution, AgNO3, in aqueous, and a precipitate formed of silver halide. So pretty simple. Add dilute nitric acid, add a few drops of silver nitrate solution, AgNO3 aqueous, that's silver nitrate solution, AgNO3 aqueous, precipitate formed of the silver halide. What is used to test for halides? Silver nitrate solution. Why is dilute nitric acid added in the test of halides? This is also really important. Dilute nitric acid is added in the test of halides to remove ions which might interfere with the test. So it's a basic equation: Ag plus aqueous plus X minus aqueous to form your silver halide AgX solid. So you can see the fluoride ion F minus has no precipitate. The chloride ion Cl minus has a white precipitate, gives a white precipitate. The bromide ion Br minus gives a cream precipitate. The iodide ion I minus gives a yellow precipitate. Forms slowest to forms fastest. The color of the precipitate identifies the halide. Then we want to test these results. This is a bit extra to make sure it is the halide we're looking for by adding ammonia solution. Well, each silver halide has a different solubility in ammonia. You can see chloride, Cl minus, Br minus, I minus, it goes from most soluble to least soluble. So I minus is least soluble, Cl minus is most soluble. So with Cl minus in ammonia, there's a white precipitate, dissolves in dilute NH3 aqueous. Bromide, Br minus, is a cream precipitate, dissolves in concentrated NH3 aqueous. Iodide, I minus, yellow precipitate, insoluble in concentrated NH3 aqueous. You do need to know these key details because an exam could tell you concentrated NH3, concentrated ammonia was used, and then you realize, okay, so it's not going to be Cl minus because that dissolves in dilute NH3. That's for example. Then we're going to move on to describe how to carry out a flame test. So we want to dip a nichrome wire loop in concentrated hydrochloric acid, HCl. Dip a nichrome wire loop in concentrated HCl. Dip the wire loop into the unknown compound. Hold the loop in the clear blue part of the Bunsen burner flame, and then when we want to observe the color change in the flame. If it's Ca2+, the flame color is a brick red. If it's Sr2+, strontium, it's a red flame color, and if it's Ba2+, pale green. Ca2+, brick red, Sr2+, red, Ba2+, pale green. How to use dilute NaOH solution to help identify group 2 ions? Well, you want to add NaOH, sodium hydroxide, dropwise to a test tube containing the metal ion solution. Add NaOH dropwise to a test tube containing the metal ion solution, and then we want to observe the precipitate formed. You want to keep adding the NaOH to excess. Keep adding NaOH to excess, and we want to record any changes observed. And this is using dilute NaOH solution. So Mg2+ with OH minus is slight white precipitate, with excess OH minus it's white precipitate. Ca2+ with OH minus slight white precipitate, with excess OH minus slight white precipitate. Sr2+ with OH minus slight white precipitate, with excess OH minus slight white precipitate, and Ba2+, no change with OH minus and with excess OH minus. What do hydroxide ions do? OH minus ions make the solution alkaline. Which metal ion group 2 is no change with OH minus with excess OH minus? Ba2+, barium. You can clearly see no change with OH minus, no change with excess OH minus. What is ammonia? Alkaline. Obviously that's not what ammonia is, but well, it is what ammonia is. Ammonia is alkaline, and that's why we're going to use it now. Just so you guys know that it's alkaline. So describe how to use red litmus paper to test for ammonium ions. Well, you want to using a damp piece of red litmus paper. The litmus paper must be damp. Why? So we're using a damp piece of red litmus paper. The litmus paper must be damp so that ammonia gas can dissolve. And if the ammonia is present, the paper will turn blue. So using damp piece of red litmus paper, the litmus paper must be damp so ammonia can dissolve. If ammonia is present, the paper turns blue. Say the equation of OH minus NH4+, NH4+ aqueous plus OH minus aqueous to form NH3 gas, ammonia plus H4 liquid, water. How to use NaOH to test for ammonium ions? Add dilute sodium hydroxide to a solution containing the substance and gently heat the mixture. And if ammonia is given off, ammonium ions are present. So add dilute sodium hydroxide to a test tube containing substance. Gently heat mixture. If ammonia is given off, ammonium ions are present. State how to identify SO42 minus the sulfate ion. We want to add dilute hydrochloric acid, add barium chloride solution. So add dilute hydrochloric acid, add barium chloride solution, BaCl2 aqueous, and if the white precipitate barium sulfate formed, the original compound contains sulfate ions. White precipitate barium sulfate formed. Here's the equation: Ba2 plus aqueous plus SO42 minus aqueous to form BaSO4 solid. Why is dilute hydrochloric acid? Why is HCl added? To remove traces of carbonate ions, as they would also produce a precipitate. HCl is added to remove traces of carbonate ions, as they will also produce a precipitate.